Hello and welcome to Chapter 2, Lesson 1, Adding and Subtracting Polynomials. Our essential question for today is how can you add and subtract polynomials? What we're going to learn is how to find the degree of monomials, how to classify polynomials, how to add and subtract polynomials in order to solve real-life problems. All right, so first thing we're going to talk about is a monomial. So a monomial is a number, a variable, or the product of a number and one or more variable with whole number exponents. Okay, so basically what a monomial is, okay, it could be either, a single number, a variable like x is a monomial, or it could be the product, or when we multiply a number and a variable or more than one variable. So like for example this one here, that's a number and a variable. This is also a monomial. It has a number, numeric value, a variable, another variable, and we have a positive whole number exponent. Number, variable, whole number exponent. Those are all monomials. These are examples of not monomials over here. So if it has a plus sign, if it has a sum or a subtraction, okay, then that is not a monomial. Okay, so we only have monomials, don't have any signs in between them. So it's all just basically a single term. A monomial cannot have a variable in the denominator. So no variables in the denominator. So in the bottom can't be a letter. A monomial cannot have a variable as an exponent. So if it's like 4 to the power of a or 4 to the power of x, that's not a monomial. And also a variable must have whole number exponents. So no negative exponents. Negative exponents mean that we have to bring that x to the denominator, which we know we cannot have variables in the denominator. Okay, so those are monomials. The degree of a monomial is the sum of the exponents of the variables of the monomial. The degree of a non-zero constant term is 0. The constant 0 does not have a degree. Okay, so what that means is we're going to take the degree of all the variables. So this first one here doesn't have a variable, doesn't have a letter, so we call it degree of 0. This one here has an x, has one variable, and remember we always have an invisible 1, so that is a degree of 1. This one over here, we have two variables, we have a and b. So a and b each have their own exponent. The a has a 1, the b has a 2, so we have 1 plus 2. The degree is 3. Okay, so whatever degree is attached to the variable, that's the degree. If we have more than one variable, then we add the exponents to get the degree of the monomial. All right, so example 1, we're going to find the degree of each of the following monomials. So we have 5x to the power of 2. So the rule for finding the degree is we take the degree of all of the exponents and add them together. It's the sum of all the exponents. So in this case, we have one variable with one exponent. So the degree for this one is 2. All right, let's divide that up. Our next monomial is -1/2 xy to the power of 3. So in this case, we have two variables, so we should be adding two numbers. We need to add two numbers. We need to add the exponent for the x, which we have an invisible 1, and we're adding it to the exponent of the y term, which is 3. So our degree for this monomial is 1 plus 3, which is 4. Then we have 8x to the power of 3, y to the power of 3. We add the exponents for all of our variables. We have 2 variables, so I need to add 2 numbers. We're adding 3 plus 3. So the degree of this monomial is 6. And then our last one is -3. So we're going to add the exponents of all the variables. There are no variables, no letters, so then our degree is 0. Okay, polynomials, right? Those are monomials. These are all monomials because remember there's no plus or minus signs in between. There is a negative sign, but it's nothing that's in between the numbers and the variables. So these are monomials. Now polynomials is a monomial or a sum of monomials. So once we start adding plus signs and minus signs in between the monomials, then we can call them polynomials. So we have 2 other types of polynomials that we kind of have a name for. Those are binomials. So a binomial has 2 terms, right? So 2 terms. So it has 5, for example, this one here has 5x separated by a plus sign, and then there's a 2. So this is 2 monomials giving us a binomial. Bi means 2. And then our the other term, x squared plus 5x plus 2, has 3 terms. So this is a trinomial because tri means 3. Now, a degree for the polynomial is the degree of its greatest term. So here we have various monomials. We have 4 monomials in this case. This first term has a degree of 3, 2, 1, and 0. So the degree of the whole polynomial is the degree of the largest monomial. Okay, so we're going to go ahead and go over an example of that in just a second. All right, so what we're going to do first is we're going to put this in standard form. In order to be able to answer some of the questions for polynomials, we need to write a polynomial in standard form. So what that means is we're going to write it in order of degree, greatest to lowest. All right, so in the previous example, we talked about finding the degree of a monomial. Okay, so what I'm going to do here is I'm going to identify the degree of this first term, which is 15x. I'm going to add all of the exponents of each variable of this monomial, and that is going to be 1. Okay, so I'm not actually adding 1 plus 3 because these are separate monomials because they're separated by a minus sign. Okay, a subtraction symbol. Okay, so then this is a separate monomial. I'm going to add the exponents of all the variables. So that's 3. And then lastly, we're going to go over this term down here, which doesn't have a variable. So the degree of this is 0. So now to put this in standard form, I'm going to rearrange the terms in order from biggest to lowest degree. So our largest degree is our negative x to the power of 3 because it has a degree of 3. Then I'm going to write positive 15x. That's a degree of 1, so that goes next. So I'm putting them in order, largest, second largest, lowest. And then the plus 3 comes at the end. Okay, so this is our polynomial written in standard form. I'm going to go ahead and type that in there. Negative x plus 15x, and I know I forgot the x squared, so I'm going to go back and add that there. Oh, it's not squared. It's to the power of 3 plus 3. and then I'm going to go ahead and submit that. Okay, so that is written in standard form, largest degree to smallest degree. And then I'm going to identify the degree of the polynomial and my leading coefficient. Okay, so let's talk about those two parts. So the degree of a polynomial, so this is a polynomial. These are individual monomials. So the degrees of the monomials are 1, 3, and 0. But the degree of the polynomial is the degree of the largest monomial. So the degree of this polynomial is 3. And coefficient, okay, that's the other. So a coefficient is the number in front of the variable. So each of these two terms have a coefficient. The coefficient for this term is 15. The coefficient for this term is a -1. Okay. So we're looking for the leading coefficient. So the leader, which one is the first coefficient? Okay, so in this case, the leading coefficient is from this term. So our leading coefficient for the polynomial, we're going to go ahead and write as -1, because it's the first coefficient. It's the coefficient that belongs to the term with the largest degree. All right, so here is a step even further. We're going to identify different parts of the polynomial, and we're going to classify what type of polynomial it is. So standard form is the first part. We got to write each polynomial in standard form. So remember, standard form, we put them in order from largest degree to lowest. Now this one here has only one term, so I don't need to reorganize it or rewrite it because it's already in standard form. It only has one term, so there's no need to add anything else. That's standard form. Now what is the degree of this? Well, it only has one variable, one exponent, so the degree is 4. And now for this part, the classification. So classifying means what type of polynomial is it? Is it a monomial? Does it only have one term? Is it a binomial? Is it two terms separated by a plus or a minus sign? Or is it a trinomial? Does it have 3 parts? Does it have a term, a plus sign or a minus sign, another term, a plus sign or a minus sign, and another term? This one only has one term. So this is a monomial. Oops. Okay. All right. Our next one is 4 plus 5x squared minus x. Now this one has various parts, so we're going to have to identify our degrees for each of the terms so that we can reorganize it in standard form. So our first term here is a 4, no variable. So if it has no variable, our degree is 0. Next up, we're going to the middle term, which is 5x to the power of 2. We have one variable, one exponent, so that is our degree for that term. And then our last one is just -x, which has an invisible power of 1. So we have that as our degrees. So now to put it in standard form, I'm going to put it in order from largest term, 5x to the power of 2, and to the second largest, which is -x, and then to our smallest term, which is +4. Okay, this is our polynomial in standard form. All right, to identify the degree of this polynomial, we're going to take the degree of the largest term, which is 2. So the degree of the polynomial is 2. And what kind of polynomial is this? Well, it has 1, 2, 3 different parts. So we have a trinomial. And lastly, down here, we have 8q plus q to the power of 5. So we have multiple parts again, so we have to identify the degrees. This is q to the power of 1, so the degree is 1. And then our second term here is has a degree of 5. So I am going to have to reorganize this. So largest one goes first, q to the power of 5. And then I have plus 8q. All right, q to the power of 5 plus 8q. And then we'd look at the degree. The degree is the number that is the highest degree of the leading coefficient of the leading term. So that's 5. And notice how right now we're going to see that this is actually has two terms, has q to the power of 5 and 8q. So this is a binomial. All right, and notice how there is not really a relationship between the degree and the classification. So the degree could be as high as possible, and we can still have a monomial. We can have a very low degree, like 2, and still have a trinomial, has more parts. Or we can have a really high degree, like 5, and have a little bit of terms, so binomial. So that doesn't relate. It matters how many terms are in the polynomial, and then the degree depends on the highest degree of the largest monomial. All right, so adding polynomials. So when you're adding a polynomial, we're going to have to do, it's basically like adding regular numbers. The only difference is that we can only add the terms that are the same with each other. So if I have this first one where I have 2x to the power of 3 minus 5x to the power of 2 plus x, and I'm adding it to my second polynomial, which is 2x to the power of 2 plus x to the power of 3 minus 1. Okay, so the problem, or I guess not the problem, but the difference between adding normal numbers and adding polynomials with each other is that I can only add the terms together that have the same sign, that have the same degree. So what I'm going to have to do here is I'm going to have to identify the parts that I can add with each other. So I can take this part and add it to this one because they both have x to the power of 3. So I'm going to go ahead and just add those two together. So I have 2x to the power of 3 and 1x to the power of 3. So all I do is add the coefficients. So I add the numbers in front. So that's going to give me 3, 2 plus 1. And then I leave the same variable and exponent. So the only thing that changes, the only thing that gets added are the numbers in front of the variables. I have negative 5x to the power of 2, and if I look on our second polynomial, I have another term that has x to the power of 2, so I can add those two together. So I have negative 5x to the power of 2, positive 2x to the power of 2. So remember, I only add the numbers in front. So negative 5 plus 2 gives me negative 3. And then I don't do anything with the x squared. I just bring it down, x to the power of 2. Okay. All I do is add the terms in front of the x, of the variable. Here I have an x term, just an x by itself. On the bottom one, there is nothing that just has an x, right? So I can't add it with anything. So I'm just going to go ahead and bring it down. And then the 1 is just a number. There's no single numbers that I can add it to at the top. So I'm going to go ahead and also bring that one back to the bottom. And then this is my final result. 3x to the power of 3 minus 3x to the power of 2 plus x minus 1. Okay, that is the sum of these two polynomials. Okay, I'm going to go ahead and repeat that one more time down here with the second problem. So I have 3x to the power of 2 plus x minus 6. And I'm adding that to x squared plus 4x plus 10. All right, so I'm going to go ahead and search. I'm going to start from the largest degree, which is 2. And then on the second polynomial, I'm going to find one, if there is one, that I can add it to that has the same variable and exponent. So I have two terms here that have x to the power of 2. So I'm going to add the coefficients only. So this is going to be 3 plus 1, which is 4x to the power of 2. Notice that the exponent doesn't change. It's still x to the power of 2, not x to the power of 4. Okay, so we're only adding the the numbers in the front. So then I keep going. So on the top I have my next term is an x. This one down here has an x as well. So then I have to add the coefficients. 1x plus 4x gives me 5x. And then I have a number by itself. And on the bottom, I also have a number by itself. So I can combine those two together. Negative 6 plus 10 gives me positive 4. And this is my final answer for the sum of these two polynomials, 4x squared plus 5x plus 4. All right, so subtracting polynomials is very similar to adding polynomials. So the only difference is, check this out. So I have 4n plus 5. And then it says I'm subtracting. So in this case, I'm subtracting negative 2n squared plus 2n minus 4. So before I can combine the terms together from both of these polynomials, the first thing I have to do is, because I'm subtracting, what I'm going to do is I'm going to change the signs of everything inside the parentheses, because the negative changes that to a positive, changes that to a negative, changes that to a positive. You're basically just switching all the signs of the second polynomial. Alright, so I'm going to go ahead and do that over here. So the first one stays the same, 4n to the power of 2 plus 5. The second one, I'm going to write it basically the opposite. Everything changes sign. So I have a negative 2n to the power of 2. That becomes a positive 2n to the power of 2. The middle term is a positive 2n. I'm going to write it as negative 2n. And then the 4 was negative, so I'm going to make it positive 4. All right. And basically now what you do is you do the same thing we did with adding. So I have a 4n to the power of 2 as my largest degree, and I have a 2n to the power of 2. So I can now add those two together. So then that's 4 plus 2, and I'm going to keep my n to the power of 2. My next degree, I'm not going to go do the 5 yet because I have a term that has a degree of 1. So I write all the variables first. So then this is going to be, there's nothing on top that I can combine that with, so I'm going to bring it down. And then lastly, we have our numbers, 4 and 5. Positive 4 plus positive 5 gives me a positive 9. So this is my final answer for finding the difference or subtracting two polynomials. Okay, and notice how I went in order of degree so that my final answer is written in standard form. Highest degree first, second last. So this is 2, 1, and 0 degrees. All right, let's try the next one. We have 4x to the power of 2 minus 3x plus 5, and I'm subtracting 3x to the power of 2 minus x minus 8. Okay, so before we combine these, I'm going to take the top one. I'm going to just go ahead and rewrite it just how it is. Change nothing to it. Exact same. And the second polynomial, the one that's being subtracted, I'm going to change the signs of everything inside the parentheses. So 3x squared was positive. Now it's negative. The negative x becomes a positive x. And the negative 8 becomes a positive 8. So now let's combine terms that are alike, like terms, combining like terms. 4x to the power of 2 plus a negative 3x to the power of 2. That gives me 1x to the power of 2. Negative 3x positive 1x gives me a negative 2x. And positive 5 positive 8 gives me a positive 13. Okay, and that is how you subtract two polynomials from each other. All right, that is the end of lesson 2.1. You should have learned what the difference is between a monomial, binomial, trinomial, and polynomials. You should know how to add polynomials and how to subtract polynomials. If you have any questions, comments, or concerns, please feel free to leave those in the comment section down below. Till next time.